When data used to train a model sits in memory, we can create an input pipeline by constructing a dataset using tf.data.dataset.fromTensors or tf.data.dataset.fromTensor slices. FromTensors combines the input and returns a dataset with a single element, while FromTensor slices creates a dataset with a separate element for each row of the input tensor. Here is an example where we'll use text line dataset to load in data from a CSV file. This is a dataset comprising of lines from one or more text files. The text line dataset instantiation expects a file name, and it has optional arguments, for example, like the type of compression of the files or the number of parallel reads. The map function is responsible for parsing each row of the CSV file. It returns a dictionary from the file content. Once that's done, shuffling and batching and prefetching are steps that can be applied to the dataset to allow the data to be fed into the training loop iteratively. Please note that it's recommended that we only shuffle the training data. So, for the shuffle operation, you may want to add a condition before applying the operation to the dataset to ensure that it's training. Finally, we have to address our initial concern, loading a large dataset from a set of sharded files. An extra line of code will do. We'll first scan the disk and load a dataset of file names using the dataset.listFiles functions. It supports a glob-like syntax with stars to match file names with a common pattern. It's pretty useful. Then we'll use the text line dataset to load the files and turn each file name into a dataset of text lines. We flat map all of them together into a single dataset. And then we map each line of text. We'll use that map to apply the CSV parsing algorithm and finally obtain a dataset of features and labels. You might wonder, why are there two functions for mapping? Map and flat map. Well, one of them is to simply do a one-for-one transformation, and the other one is one-to-many transformations. Parsing a line of text is a one-to-one transformation, so we use map. When loading a file with text line dataset, one file name becomes a collection of text files, so that's a one-to-many transformation, and it's applied with flat map to flatten all the resulting text line datasets into a one. Dataset allows for data to be pre-fetched. Let's say that we have a cluster with a GPU on it. Without prefetching, the CPU will be preparing the first batch while the GPU is just hanging around doing nothing. Once that's done, the GPU can then run the computations on that batch. When it's finished, the CPU will start preparing the next batch and so forth. You can see that this is not very efficient. Prefetching allows for subsequent batches to be prepared as soon as their previous batches have been sent away for computation. By combining prefetching and multi-threaded loading and pre-processing, you can achieve a very good performance by making sure that each of your GPUs or CPUs are constantly busy. Now that you know how to use datasets to generate proper input functions for your models and to get them training on large out-of-memory datasets. But datasets offer a rich API for working on and transforming your data. So let's take advantage of it.